When I mention the word work, what is the first thing that comes to your mind? Number crunching the calculators, writing an endless report, or meeting the given deadlines? In physics, when we talk about work, we have a very specific definition and formula that has nothing to do with the report and deadlines. In this lesson, we are going to learn what is the definition of work and how to calculate the amount of work using an example. To understand work, you need to understand force. Force is an external agent capable of changing the state of rest or motion of a particular body or system. For example, this toy truck is moved by the external force, which is the index finger, whereas a system is an object or part of a new universe that you are studying. For example, if you are using a rope to pull a toy cart across the floor, the toy cart is what we call as a system, and the force that you are using to pull the toy cart is an external force. Let's say that the toy cart has been pulled with an external force of 40 newtons and has been moved across the floor for 5 meters. Therefore, the work that have been done on the toy cart is 40 newtons times 5 meters, which is 200 newton meter. More commonly, we can express the work done in a unit known as joules. From the example that we used just now, the force used to pull the toy cart is parallel to the ground. Now, sometimes, the force that you use would not be exactly in the same direction as the direction in which the system is moving. In this instant, the toy cart is still moving parallel to the ground. However, the rope is at an angle to it. With the example that we have given just now, the toy cart is being pulled with an external force with a certain angle. In this example, we have to break up the external force into two components. One that is parallel to the ground and another one that is perpendicular to the ground. Usually, we define the angle that is formed between the ground and the rope or the external angle as theta. The two components are consisting of a component x, which parallel to the ground, and the component y, which is perpendicular to the ground. To find the part of the force that is parallel to the ground, that is, the one that is actually pulling the toy cart forward, you just need to multiply the magnitude of the force by the cosine of the rope's angle to the ground. Therefore, 40 newtons cos 60 times 5 meter is equal to 100 newton meter or 100 joules. You can see that with two different ways of pulling the toy cart using the same amount of force will give you two different level of works.